is safe control of work. On behalf of Rifle Shot Performance Holdings, I would like to thank the Southern African Institute of Mining and Metallurgy for hosting this webinar on our behalf, and in particular the steering committee, Camila Jardine and Gugu Charlie, for their input and assistance. Please make sure your microphones and cameras are off until we get to the Q&A session at the end. But please feel free to post questions and comments in the Q&A and chat boxes throughout the webinar, and we will attempt to answer all of them if time allows. I'd like to introduce Billy Naidu, Chief Vision Officer of Madala and Associates and Business Development Director of Rifle Shot Performance Holdings. Dilly is an internationally experienced business leader with over 45 years of experience in large corporates and government institutions. Dilly has more than 35 years of experience in the industrial sector and has a keen interest in human interactions, studying the interactions between different cultures and their environments. Dilly, over to you.
Thank you, Caroline, and welcome to everyone. As you would notice, I'm wearing part of my PPE, which is a hard out, as well as a reflective jacket. In Rifle Shot, as well as the industry, and in particular the mining sector, we start with the safety moment, and now we call it an ESG moment. So the prerequisite to stay with us on this conference is to make sure that all of us have some form of safety wherever we are. I wanted to make it a prerequisite, but I'm sure you are in a proper environment, either at home or in the office, or even on site, watching offline, that you have the appropriate PPEs. Companies have done an amazing job in terms of compliance with PPEs. I guess because it's very conspicuous and it's visual. However, we believe that companies need to start establishing a sense of safety in terms of moving into the digital age with electronic permit to work. As an example, this morning I was at the gym in Virgin Active in Grayston Road in Sandton, and they are busy reconstructing the ceiling. And what caught my eye was in the middle. So those of you who train at the Virgin Active in Grayston Drive in Sandton, the pool is not in use because there's a steel scaffolding there. What caught my eye was there is a notice on the steel scaffolding: do not use the steel scaffolding because it is not in full use at the moment. So that's a compliance thing. But what will stop somebody who doesn't have a permit to have access to something like this? So with that, let's begin today's session. As Caroline mentioned, it's a very, very important session. We'd like to share a little bit about ourselves, just a snapshot of who we are before we move to the rest of the sessions. So as Rifle Shot, we're proud to be celebrating over 2 decades of enhancing our clients' business as well as operational performance. And as you notice, we do this with the social conscious. It's part of our DNA. It's not something that we comply with ticking a box on an ESG compliance. We've also invented a term some time ago that we call Innovation Cube. So if we embark on a project with you and customers that are joining us today, we'd notice that we ask you the question, why are you doing this? We try to understand. So it's the way we think before we apply technology. We also make sure that our clients that we work with, that we are transferring knowledge in terms of developing the skills and making full utilization of the technologies that we provide you this. A number of your organizations are embarking on what is called a business transformation through digitalization. Again, you'll see we've invented another term called bridgitalization, because what you're actually doing is you're starting to build a solid journey foundation, and we move you through that through a common thread called digitalization. And we do this through specialized core competencies that we have, which we call SMEs or subject matter experts within our organization. Today, we're joined by some of our members that are subject matter experts in the electronic permit to work area. And we do this with the environmental, social, and governance mindset. You'll also notice another term. As opposed to consultants, we invented the term resultants. So what is a resultant? A resultant is somebody that partners with you on a journey as a client, and we work with and through you with measurable milestones on a quarterly basis, something that's called agile today. But we started long before the term agile was invented. It's based on what we deliver as opposed to the PowerPoint presentations that we share with you or brochures. So there's a lot more information on the organization, but I wanted to start off by sharing an incident that took place a little while back in Australia. And you would notice this Land Rover is doing a bit of a post-mortem view of a runaway train. And this train was traveling at 140 kilometers per hour. It was carrying 42,000 tons of iron ore. It had 2 locomotives with 245 ore cars. And it's amazing that this was a runaway, and you could see the aftermath of some of the damage. There were 2 kilometers of rail track that was damaged. And based on the post-mortem, there was an equipment failure. There was an operator error. The brakes that were applied manually was applied to the wrong train. So you can see a whole number of things that happened that created this kind of disaster. Other than the human impact and the infrastructure impact, but the business impact, the bottom line impact to the business was an average of $45 million per day in terms of lost productivity. Now that's, just giving you a feel in one particular area, what the impact is, not only on the human side, but on the business side. So what I wanted to do in the few minutes is to give you a global view of some of the trends in what we call the employee control of safe work. And as you would appreciate in your organization, there's lots of moving parts. There's lots of movement of people, equipment, machines, and of course the environments, either in an open pit, surface level, or underground. There's gases, there's all kinds of things, explosions that are taking place. So there's been some studies done about a year ago, a global study by an entity that's called the Global Guidance Group in the mining sector. They did a roundtable as well as research with almost 260 participants, and they looked at some of the key challenges in the mining sector. And I'll touch on 3 of the top priorities. And one of the top ones was enabling innovation and technology adoption. It's one of the key things. And how do we get the foundation and the basics right so that you can go on this journey? The second was the whole area of data integration and management. I quite often use the term data everywhere, but no insight in sight. So the whole area of how do we connect all the information that we have so that you can make meaningful decisions based on valuable insight. What we are talking about today is the third one, which is the people, safety, workforce, and training. There is no doubt globally, including in South Africa, where people in the industry are either retiring, in some cases migrating, and there are fewer attractions of younger people into the industry. So a number of the companies that we deal with are having a balance between using technology to improve their productivity and automation while complementing that with new skills development. So a little bit of insight into the area of what we call operational risk management. And this was a survey that was done in the industrial sector, quite a balance between the oil, gas, petrochemical, manufacturing, both process and discrete, the mining sector, as well as the power generation sector. And as you could see, the focus on operational excellence within this environment for the next 2 years. The question that was asked, to what extent are the following operational initiatives your firm to improve the next area? And you'll see the number one area with 66% focus for the next 2 years or so is environment risk mitigation with 66%. The second was safe operations at 55%. So if you combine environmental risk mitigation and safe operations, that's a very, very large focus, not only in South Africa, but around the mining sector globally and the industrial sector as a whole. Something interesting in terms of the market for operational risk management, and in particular, what we call the employee control of safe work. In 2021, there was $455 million spent. The forecast is in 5 years, from 21 to 26, it'll be more than double spent on software just for the management of safe control of work. And that's a very impressive compounded aggregate growth rate of 23%. And if you look at the rest of the IT industry spend, you're talking about single-digit numbers. So a very big focus, and this is very, very important. In terms of the software, the question that was asked to the participants, what are your plans to invest in employee control of safe work software? And you could see from the pie chart in front of you, there's 35% of companies, which is quite encouraging, that have already invested in software. They have no investment plan. There's 26% that would upgrade existing software to a more modern piece of software. 13% will replace in-house software with commercial software. In a large number of cases, that in-house is either bespoke or it's Excel spreadsheets. 12% says we don't have software, no investment plan. And then 10% says they'll replace existing commercial software with software from a EU vendor. In other words, they've embarked on the right track, but they've realized that they've matured, they need to relook at the marketplace. So some of the challenges in the current control of work environment, what we find is, as much as companies are talking about business transformation through digitalization, there are companies that are still on a manual paper-based system, including Excel spreadsheets. And you'll hear from one of our clients that embarked on this journey with us since 2015, that moving from a paper-based system to an electronic-based system has huge advantages. So if you look at a paper-based system, there's risk of abuse. The paper can get lost, numbers can be changed, and there's no date and time stamps in terms of audit trails. There's also long lead times to issue permits, and that causes a huge problem if you've got thousands of contractors or permanent employees. More importantly, today in the digital environment, in the entire company ecosystems, there's no integration. One of our large companies that we have been working for almost 15 years is Eskom, integrated from Koeberg nuclear power station to every power station around the world. And when they have a shutdown in Koeberg, they're issuing something like 6,000 permits. So they use biometrics for access control. The employee compliance. So if you have a work task order, how do you link this up to your competency management system to look at the employee that's going to perform the task is capable and has the skills to do that? Integration to plant maintenance to make sure that whatever you have in your plant maintenance ERP systems, the SAP and the likes of ERPs, that the maintenance has been done on that. And last but not least, there's a whole governance risk and compliance. So with an integrated system, electronic permit system, you'd be able to enjoy these kind of benefits. A very quick snapshot on some of the technology trends. I'm sure you're familiar with these things. When I was growing up as a young boy, when you mentioned the word cloud, I looked up into the sky. Today, when you mention cloud, I visualize a data center sitting somewhere in the world that I'm accessing information to. Some of the benefits of having a cloud is obviously there's no cost in terms of infrastructure other than an access device. The speed of execution, you can start small and scale. And of course, the issues around cybersecurity is taken by the cloud provider. Big focus with clients that we're working with, the BHPs of the world in Australia, Rio Tintos, Qatar Energy in UAE, etc., are focusing a lot on mobility and what we call the connected worker, who's doing remote maintenance, etc. So mobility is a key area where you can actually start creating and sign permits on the field, and you can work offline. Last but not least is visualization. So you could have dashboards, and in some companies, they have these large screens posted on their walls where you can actually look at the status of permits on a dashboard. Companies in Australia and Canada are already embarking on 3D models and are moving in that direction right now. And of course, the whole geographical information systems incorporation, you're able to visualize the actual area where these incidents are taking place. So to conclude, why are mining companies prioritizing in this employee control of safe work through technology? It is obvious. The first one is to do the risk assessments through a tool that we have, like electronic permit to work, to minimize the risk. Big focus on preventing incidents so that we don't have injuries, fatalities, and deaths, to improve the compliance and make it easier in these complex environments. So that concludes my side of the presentation. With that, I hand you over to Caroline.
Thank you, Deline. Next up, we have Percy French, Divisional Engineering Manager for Control and Instrumentation at Sibanye-Stillwater Platinum Division. He holds an NH diploma in electrical engineering, light current and process control, and he has 34 years of experience in the South African mining, metals, as well as iron and steel manufacturing industries. Percy is part of the local technical schools tutor program, as it also fits in with what he enjoys the most, which is model engineering of live steam locomotives, developing electronic circuits and cross-country running, coaching. Percy, over to you.
Good morning, everybody, and thanks so much, Caroline, for that introduction. Dilly, thank you so much. I think a much appreciated presentation that you've given there and insightful. Can I just get Caroline? Can you hear me clearly and can you see me?
We can hear you. Thank you, Percy.
Okay, thank you. So we can move on with the presentation. Okay, so in our excursions within the mining industry, within the platinum, we were at a stage in 2014, 2015 being challenged with regular stoppages by the regulatory bodies due to our permit and risk assessment documentation that was not compliant to full and good quality inputs. And in addition to that, at that specific stage, we were hampered with a stoppage of one of our sister mines or neighboring mines due to a fatality that occurred when, especially in my field of instrumentation and control, a actuator or a spring-loaded actuator failed, causing a multiple injury to approximately 7 individuals and a fatality of one person. During that investigation, the one key thing that came out is that the risk assessment and the permit system that the company has followed at that stage was not completely and fully properly done, and that led to poor management, decision making, as well as the fatality that eventually ended up costing the company a significant amount of compensation that had to be paid out. You can move on. Okay, so what we were looking for at that stage was to have a paperless system that could basically help us to manage our risk, improve our efficiency. That is very simple and reliable, you know, and that is most importantly an auditable and cost-effective system. During the investigations, we came up with the system that we are currently using, which we have acquired from Rifle Shot, and I must be proud to say it is a system that is growing as we speak within the various operations. So allow me to just take you through a couple of the physical permit to work document, so that I can just demonstrate to you how this has basically aligned with our goals that we set for ourselves. Starting off with the first slide here, this one basically helps us to ensure that our permit initiator and permit artisans, contractors, that they need to basically think all their risks properly through prior to start with the work. And what the permit system also allows us to do is for all our risk analyzed work to create basically a risk assessment standard for that specific tasks and jobs that they are supposed to be doing. But what is very important to notice here, this permit system as it is currently mitigates the stereotypical type of behavior that people will have just to go, you know, and select the risks as they think it through. The system basically alters the questions as it goes through the various process, so that any individual that do create a permit and analyze the risk that he's going to work with, he needs to think through them properly and make a selection of those risks. We can move on, Caroline. So what it also helps you to do as part of the preparation process, it highlights to you what is the predefined PPE that you should be allowed to do that specific task. Furthermore, it also gives you the capability for additional PPE that you might require or have on you to go and proceed with the task, to make that selection as evidence that you have had it in your possession before you started with a task. We can move on. What is also very important to notice is that this system also manages risks in the way that it also warns the permit issuer as well as the permit holder of any other work that is currently on being executed in a specific area, which is very close to where this permit will be issued to. So it's an early warning system and information system for all work that happens at any stage during the time of the permit that is being issued. We can move on. Furthermore, how it reduces basically idle time and increase our efficiency. It is an informative system that allow management and as well as the permit issuers of the current state of the number of permits that is currently issued to a specific area. But what is more important, it provides a warning system for a permit issuer of a group of people that ran out of the estimated time that they would be, what they were supposed to be spending on the specific task. As you can see in the slide there, there's a red triangle indicating to the permit issuer that this specific task is overdue and it might require further investigation on what the reason for that might be. You can move on. In addition to this, it is a very open system, and as Dilly has indicated, it provides the architecture that allows you to connect to various other business systems, as you would see later on in my slides. But what I'm presenting here to you is the ease of connectivity to our SAP maintenance system. In the past, the artisan would have to fill in all the work that he needs to execute on a permit. this thing is linked to our SAP ERP system, and as the permit developer is developing his permit, he would basically just select the works order, and it will populate automatically within the permit system the area, the specific task, and as I've explained, pre-populated risks pertaining to that task in the rest of the permit. You can move on. It's a very simple process to learn as well as to install. Since this is a thin client URL type of web-based program, it's simply emailed from one user to the other. And if he's registered on the system, he would automatically be available to log on. And on the right-hand side of the slide, you can basically see how simply it provides the workflow in a step-by-step methodology on how to flow through the process of initiating the permit, getting acceptance for all the risks and PPE requirements, then going to the next step of getting the indemnities in place, and then going to authorization, and eventually, when the task is complete, sign off and close out by the permit issuer. As I said, what we've realized is we've basically just went through a 1-week training with our operational teams and contractors. From there onwards, they basically started to train themselves. And as new employees came up, they also basically just learned the one from the other. Very, very simple process, and it's self-explanatory as I've explained. You can move on. As I've also indicated, the system is fully integratable. You can integrate it to your time management systems, your security, your domain security systems. So by utilizing biometrics and mobility devices, you know, these systems can completely become customizable for your operations requirements in terms of hardware and you know, security purposes. You can move on. Technically, this is the architecture, what it looks like. So you will have like the permit issuing or the permit development computer system at the left-hand top corner. Then it's a XML web-based service, as I've explained. Then it sits on top of a SQL database that basically captures all the information that is entered from the various users into the system, integratable to the systems as I've explained on the right-hand side, and with lately it is now a fully mobile capable system that could be used basically on any Android or iOS devices, making it easier for people that is working in remote locations that is not close to desktop computer systems, or what we have introduced, and I think some of our sister operations is what we call stations, kiosk stations, where people can go and create their permits wherever they are in the operations if they do not have mobile capabilities. You can move on. What makes it even more specific to requirements in terms of auditability, the system provides a full reporting services where anybody that is in a specific management position, whether it is a direct supervisor or it is part of the safety management, you could retrieve reports specifically related to various types of requirements that you might have in terms of the permit. In other words, you would like to have, for an example, understand how much is the menu, how many type of outstanding permits is there, how many permits did the specific person do, how many permits is overdue, and so on. So there's a wide variety of pre-populated reports that you can retrieve from the system that you can use to manage and you know, improve your risk and your permit requirements. You can move on. As I've explained, in terms of the auditability, you can clearly see in the presentation here, this permit basically provides all the information in terms of who created the permit, what is all the safety requirements. This specific permit shows that it's not been issued yet for any work, and hence the red status at the back of the permit. And you know, to me, that is one of the big things that we have encountered ever so often with permits, the paper-based permits, that people getting quite short-tempered and will not wait for the approver to approve it, and then sometimes go and work illegally without a permit being issued to them. And that was one of the a couple of findings that we have had in the past with the paper permit system, where our regulatory bodies basically identified such behavior, and it was very difficult to control. With this now, it's open and it's available for us to monitor at any stage and time of day. You can move on. I think in essence, what we are trying to bring to you here is the permit system, as we've set it out for us in the beginning, to be a easy, simple system, a system that can manage our risk, you know, to allow us to train our people on the various risks and create a behavior where they could basically be more effectively utilized. The system as it is has basically provided all of that, and above all, it creates the visibility to our operational staff on a daily basis on where our work is happening and what is the amount of workforce that is currently working in any area. I think in conclusion, this is what I can bring to you to just tell you how this worked for us and is still currently working for us, and we are moving into different areas to implement the system as well, not just only in our processing and mining facilities, but also in our surface operations, which is now in a broader and wider area of around about 50 kilometers with mobility going into the future. Thank you so much.
Thank you very much, Percy, for taking us on the journey with you. So you've seen the screenshots of the electronic permit to work. Now Hope is going to take you through the live system just to illustrate mostly ease of use and how to go through the issuing of permits system. Hope is our training and implementation consultant. She is very enthusiastic, passionate, and very well respected among her peers. You'll see. Hope, over to you.
Thank you for that introduction, Caroline. Good morning, everybody. My name is Hope Tazana, and I'll be stepping you through the process. I'm very pleased to be presenting to you all. I'm just going to share my screen. Okay, so I'm going to show you how a digital permit is created from the time an artisan initiates a permit to work until the last step in the process where the tools have been handed back to production and the artisan has signed off their permit. So what you're seeing in front of you is that permit list or dashboard that Didi was referring to, that will be typically in control rooms where the production personnel can have a 24/7 view of what is happening in the plant, and they'll be able to do so by tracking the statuses. So just a little on the permit list. Each time a permit is initiated, the system will generate a serial number or a permit number which anyone in the plant can use to search for the permits. And you'll also be able to see the job description of the permits that you're looking at just on the dashboard without necessarily having to open that permit. You can see the issuers as well as the requesters of the permits. And then just very quickly, this is how an artisan would create a new permit. On the right-hand side, sorry, under common tasks, they would click on add new. Okay, there seems to be load shedding in the area, so the connection may be a bit slow, but let's get right into it. Okay, so what you see is this permit wizard that is guiding the artisans as they step through the permit. So we're going to work through the permit slowly so that you can see that ease of use that Caroline was referring to. So firstly, the artisan would search for that work order number that they receive on their job card when the planners give them their work package. They would enter the work order number or the notification number, click on the magnifying glass, and the system will bring out the notification or the work order numbers based on what they've searched. And they would select that work order, click on select. So depending on how your data management system is maintained, sometimes it will pull up the job description, the plant area where you're working, or the discipline, depending on how you customize it for your site. So from there, the plant area is already selected for us from our SAP. We now select the work permit type. I'm going to select a work permit for this exercise. And I've had instances in sites where sometimes the artisans will say, well, ma'am, sometimes the planners don't quite describe our task the way that we'd like because they're not the ones executing the task. No problem, Mr. Artisan. You can just simply edit out the description and describe the task the way that you would like. Okay, so I'm just going to add that job description there. From there, they would estimate when they want the permit to be prepared by. So I'm just going to select any time, 3 o'clock. And then they would estimate how long the task is going to take. And then on the left-hand side, this is where they select the supporting activities or checklists or permits that are required to execute the task. So it can happen that sometimes they require a hot work permit and also confined space clearing. So the artisan will be able to select multiple permits and not necessarily have to create multiple permits to have all that information. But for this exercise, we are just going to repair a pump in the workshop. So I'm just going to select a single hot work permit. From there, the artisan will click on next, and you see our wizard has moved us to our links page. So on this page, we focused on the equipment that we're going to be working on. Already our data management system, SAP or Oracle, would have given us that equipment that we're working on, and we can also add or remove if necessary. So I'm going to now click on next. You see it takes us to your hazard page. So the first hazard that you will get will be dependent on the activities that you selected. So we're doing a hot work permit. You'll see your first hazard is that hazardous hot work. From there, the artisan can select additional hazards that are required for their task. So obviously, in this regard, they're being guided by the SLAM or checklist that they use when they're assessing the areas, whatever the case may be. They can just select the hazards that are present in the area that they're going to be working. So I'm just going to select dust because I know that's mostly common in the sites that I've visited. So from there, the artisan will click on next. The system will take you to your PPE stage. The first PPE will be mandatory, and they can't be selected because you find it is always the PPEs like your helmets, in some instances, your respirator, which we know that in the plant, everywhere you go, you always have to have your respirator with you. They can select goggles, gloves, and this list typically will include all the PPEs present that an artisan would require, but just for this example, we included a few just so you see what that looks like. From there, the artisan would click on next. So we have two types of questions in the system. We have controls and preparations. The artisans would then have these questions triggered based on the activities that they selected. So I'm going to answer the questions very quickly. The way that they can answer, they can select yes or not applicable, depending on what answer is required. So I'm going to answer some of the critical questions incorrectly, just so you see what the system does when an artisan does not answer a question correctly. From the controls, I'm going to click on next. It takes me to my preparations. So you'd have seen in our activity, I deselected that confined space permit. So I do not require that atmospheric testing or ventilation. So I'm just going to select not required for those. And then from there, the artisan would click on finish. So this is where the business rules come in that we use to govern how the system allows or disallows for permits to proceed. So where you see in the severity, it's giving us a disallow. So that means that the system will not allow us to proceed with that permit unless we change the way that we answered this question. So it's asking us, has their fire protection equipment been positioned within a suitable range of the hot work activity? I said not applicable. The system is disallowing me because it is a critical question. It will only allow the permit to proceed if I answer yes. Sometimes in a severity, you can get an alert where the system will tell you this is the answer that we required, this is the answer that you gave, but because it's an alert, it will still allow you to continue with the permit. And the other exception will be a raise exception where you can give a reason for why you answered the way that you did, and the system will still allow you to proceed. So what we need to do now is address our disallow. Already you see that it's highlighted for you. So all you need to do is just change that specific safety concern that the system is not happy with. From there, you can attempt to finish. Now you see that our permit is created and there's our serial number 10486. So we're just going to review the permit that we created. Okay, so here's our permit. It's showing the information that we entered, the work that we're doing, the area that we're doing in it, and the work order, the activities. Obviously, if we required multiple permits, we would have your hot work, confined space, working at heights, etc. in that activity there. But for this exercise, we just have that hot work and the discipline of the artisan there, the equipment that we are working on, the hazard they selected, the question and answers, and the PPE that they require for the task. And everything that we're doing on the system, it is telling us who is doing it, the name and the surname of the person with the date and time to the last second. From there, the permit will go through a workflow process. This is where all the signing happens. So the permit issuer will click on permit issuer. They'll have questions asked for them to answer before they can sign. So they're asking them to ensure that the controls are in place. If there's any hazards that needed addressing, have there been any conditions that have been changed, they would then click on continue. This is how you sign on the system. You would enter the first 3 letters of your name. The name comes up. You select the name and then you type your signature. So every signature will be unique to the different users. So we will set up the competencies for a user depending on whether you're an artisan, you would have different restrictions, and as well for the authorizers will all have different competencies based on what role you play in the permit process. So the issuer would enter their password, click on sign. You'll see now that the permit status has changed. It is showing you that the permit has been issued, and everything that you're doing, it is updating in the signatories in real time. What we've just done, it's showing there that our permit issuer, the name and the surname of the issuer, date and time to the last second. From there, the permit, the authorizer would then click on person in charge, or the executor rather. They would ask them to verify that the isolations are in place and that they have notified the people that are doing the tasks of the hazards. And if there are any controls that they need to address, the person in charge would also enter the first 3 letters of their name. Their name comes up. They also add their own unique signature. Click on sign. So sometimes depending on the business rules that are applicable at the different stages, you will get an alert, a disallow that looks quite like this. But again, where you get an alert, it is still okay. The system will allow you to continue. It is just alerting us that there's work taking place in this area that we're selecting, that we're creating this permit. But because it's an alert, it will still allow us to continue. So we'll just click on continue. Now you see that the status changes again. And the workflow will change as well. And again, everything that we're doing, it is updating in real time in the signatories as we're doing it. So from there, if it happens that at any time during the task, there has to be a transfer of shifts, the next person that would be taking over would click on that transfer and the system will automatically log off the previous authorizer. And if that is not the case, then the artisans that will be working on the task would then click on worker sign on. So the first artisan would enter the first 3 letters of their name comes up, they type their own unique signature, click on sign. You see on the workflow that it's signed with that one there. And if it happens that there's more than one artisan working on that task, the other artisans, like the first artisan, will also click on that sign on there. So from there now, our permit is now authorized for the artisan to go and work. Once the artisan has completed the work, they'll come back to whether it's a kiosk or their cell phone or their PC, click on sign off. Okay, so I'm just going to check which artisan signed on here under that worker sign on. So you can check that by having a look at the person there, and it will show you the users that have that capability to sign this. So let's just check on the signatories. Let's choose the one. So once the artisan has completed their task, they can click on sign off. Enter the first 3 letters of their name comes up, they'll type their signature and then click on sign. Then you see that sign off there. And the last step in the process will be for the authorizer to verify that the task was completed the way that it should be. If there was an isolation present, that the de-isolation has been done, the tools have been handed back to production, the housekeeping has been done. And if all that is in place, they would then click on permit completion. They'll ask them, is the work complete? Has the site, the housekeeping been done? Is the equipment tested and safe to use? Have the locks been returned? And they'll always be notified to notify the plant owner of any incidents that may have happened. And before leaving, they would let the plant owner know. Once they've answered the questions, they'll click on continue, enter the first 3 letters of their name. Their name comes up, enter their unique signature, sign their permit. Okay, so it appears that one of the workers that were working on this permit have not signed off. So this is another business rule that you get in the process. So we just always need to make sure that everybody that signs on will sign off before the permit is completed. Okay, so let's just check who hasn't signed off. Oh, there we go, our permit has signed off. So the last step in the process will be that permit completion, where the authorizer closes off their permit, and then it will go to the planners for filing. And that's it from me.
Thank you very much, Hope. And thank you for sharing your time with us. Hope's actually on site, busy with a major implementation, and she joined us in her lunch hour. So we really appreciate your time.
Thanks, Caroline. I'm going to drop off if you don't mind.
Thank you. Next up, we have Guy Imbert, who's a co-founder of Rifle Shot Performance Holdings. Guy is a chartered accountant with wide experience of manufacturing and governance, coupled with a passion for building and enhancing systemic efficiencies. This ties in well with his roles in finance, operations, and governance, where he's been known to not only lead, but also participate in detailed design and system configurations, primarily in gold and steel smelting. And if you can't find Guy in the office, he's probably off mountain biking. Guy?
Thanks, Caroline. Battling to unmute there. I hope you can hear me now. Caroline?
I can hear you, Guy.
Thank you. Cool. Right. Welcome, everybody. We're now going to move forward and watch a short video. And this video is all about Piper Alpha, which is designed as an oil rig. It lived in the North Sea processing crude oil. Piper Alpha was not just a oil rig or an oil rig, it was also the largest rig in the North Sea. So based on that, it was also given a modification to be able to process North Sea gas. And in that role, it was defined as being the primary platform for North Sea gas production. So it did both crude oil and gas. But in the gas role, Piper Alpha received gas from multiple different platforms around it. And pumps A and B, which you're going to meet shortly, routed this gas through the process and piped it off to shore. But on this particular night, as a lot of you will know, things went wrong. In fact, they went so very wrong that Piper Alpha earned its place in the history books for all of the very wrong reasons. Caroline, I don't have a screen up. Would you please press play?
Can you see it, Guy?
Nope.
My apologies, just a minute.
There we go. Thank you. I think we need
July 6th, 1988. 120 miles northeast of Scotland. The Piper Alpha oil rig. At 14,000 tons and 2.5 times the height of the Statue of Liberty, it is one of the largest rigs in the world.
Piper Alpha was the world's most successful oil rig. What that means was that in a single day, Piper Alpha produced more barrels of oil than any other oil rig or oil platform in the world.
A crew of 226 rotate shifts to keep the oil and gas flowing. Jeff Bollins is the chief control room operator that evening. At 9:45 p.m., Jeff suddenly hears an alarm, indicating a problem with one of the rig's condensate pumps.
Them condensate injection pumps tripped more than any other equipment we had. No panic, we knew we needed to get it back on because it was going to start affecting production.
That evening, Pump A is July 6th, 1988. 120 miles northeast of Scotland. The Piper Alpha oil rig. At 14,000 tons and 2.5 times the height of the Statue of Liberty, it is one of the largest rigs in the world.
Piper Alpha was the world's most successful oil rig. What that means was that in a single day, Piper Alpha produced more barrels of oil than any other oil rig or oil platform in the world.
A crew of 226 rotate shifts to keep the oil and gas flowing. Jeff Bollins is the chief control room operator that evening. At 9:45 p.m., Jeff suddenly hears an alarm, indicating a problem with one of the rig's condensate pumps.
Them condensate injection pumps tripped more than any other equipment we had. No panic, we knew we needed to get it back on because it was going to start affecting production.
That evening, Pump A is offline for maintenance, leaving just Pump B working. The same pump that's now been shut down by the alarm's trip system.
The condensate pumps were an integral part of the production facility. You couldn't have them both offline for any great length of time without shutting down everything.
To avoid a full shutdown, a decision is made to halt maintenance on Pump A and bring it back online. But what nobody knows is that Pump A has a fatal flaw. During maintenance, its safety valve has been removed, meaning that there is nothing to stop thousands of cubic feet of gas escaping into the atmosphere. The faulty pump is switched back on. Then, at 9:55 p.m., disaster. A spark suddenly ignites the escaping gas, and an explosion rips through the rig. Confronted by 700-degree flames, most of the 226-strong crew are now either dead or severely injured.
The nearest analogy is that it was a cross between Titanic and the Towering Inferno.
All hell was breaking loose on that rig. It was just a scene for hell. It's the only way you could describe it, a scene of absolute carnage and hell. Flames, explosions, debris. Things were escalating so fast at that point, it was almost impossible to take things in.
By 10 to midnight, less than 2 hours after the initial blast, the Piper Alpha is on the verge of collapse. Finally, the rig's legs start to give way, and the Piper Alpha starts to slide into the sea.
Where module was, and the rest of the platform just started drifting apart. And the other 3/4 of the platform just very slowly fell into the North Sea. And that's my worst memory of the night, because I know for people who were still on it, it would have gone to the bottom of the sea.
A total of 167 men lost their lives that night. Just 61 survived.
So there are several things that went wrong on Piper Alpha that evening. Firstly, the document that confirmed that valve A had been removed and the pipe had been blanked off was left on the artisan's desk overnight, whereas it should have been taken through to the operator to include in his issues register. So when Jeff went to have a look through that register following the shutdown of Pump B, there was nothing there. There were no issues. And that was when he took the decision to reinitiate Pump A. So not only was he pumping through Pump A, but although Pump B had been shut down, surrounding platforms continued pumping gas, which now had nowhere to go, as Pump B was closed off and valve A had been blanked off. So it did what gas does. It builds pressure until it started to escape. And it escaped to a point where an inconsequential little spark ignited a blaze that swept through the entire platform and ultimately cost the lives of 167 people. And so often, major accidents start with something as small and simple as that. So here's how that whole process could have been prevented with the technology available at that time. The artisan would, of course, have done his job properly and on time and taken his paperwork directly through to the operator instead of leaving it on his desk. This is essentially a core element of communication, which on this occasion fell down in the changeover of shift. And that, again, cost the lives of 167 workers. Now, any digital permit system worth its salt would have indicated to the operator that pump A was deactivated and that it was therefore not possible to reactivate that. It had been isolated, blanked off, all those good things. The action that Jeff should have taken, given information, the correct information at hand, was to communicate to the surrounding platforms that they had a situation on Piper Alpha and required them to shut down their flows of gas to the platform, which would have given him a moment to be able to resolve the situation, possibly on Piper Alpha itself. Instead, the platform was engulfed in flames. And again, had they had digital systems, there would have been no need to depend on human communication. The info would have been right there on his screen in front of him. All he had to do would have been to select it and drill down. Next slide, please, Caroline. And if you could put it into presentation mode, please. The digital permit system is generally implemented to support your own processes and procedures, which then results in a series of compliant and high quality permits that follow all of your processes. It documents the entire process with digital passwords and timestamps, and as Hope told you just now, timestamps correct to the very second, which support the actions which are delegated to each user, while an on-screen display will show you various pieces of information, including a listing of all open permits. And in the case of Piper Alpha, this would have been the source of information that Jeff would have used to save those lives. Also, being digital, data is available to other users literally from the instant that the permit is developed. No more waiting for Pete to walk it across the control room or wherever else it has to go. No leaving it on the desk, having a gust of wind blow it away. But finally, as all key stages in a permit are signed by the user with his own credentials, there's a comprehensive time-stamped audit trail. And not only is that audit trail useful in the case of an investigation, but it can also be used to identify permit elements that have been changed during the lifetime of the permit. This data can be used where necessary to develop additional training directed to those who need clarification on specific aspects of the permit process. So not only does a digital permit system make an immense contribution towards assisting personnel in avoiding accidents, towards enhancing your systems and speeding processes, but it also has a direct cost-saving impact. Consider, if you will, the cost of the impact on your communities for the mine, on your reputation, and so forth. Consider also the cost of a shut required by DMR. Weeks of downtime with no revenue while making good on the shortcoming. Then retraining personnel and so forth before you're allowed to even open up your mine shaft again or your plant again. So besides being humanitarian, there are significant business benefits to implementing reliable electronic systems. It's really no wonder then that the major players who you're about to see all use digital permits. Move through, please, Caroline. So you'll see people, there are companies, African companies, there are South American companies, Australians, Canadian companies. It's a worldwide trend, and hopefully we'll see some of you in there too. Thanks, Caroline, and back to you.
Thank you, Guy, for that sobering insight. Given that we're almost out of time, I would just like to, first of all, say thank you for all your time and interest. And we do look forward to interacting with you again at our next webinar, if not before then, where we'll be exploring value chain optimization and visualization. But I would like to open up for questions. If anyone has any, if you could please type them in the Q&A box or chat section now. Okay, one question that's come through is how long would implementing a system like this typically take? I think, Guy, that would be a question for you.
Hi, Caroline. We tend to do what you might call a pilot first, where we identify a small section of your plant and run an implementation based on the permits for that particular site. We train up your staff and test it really thoroughly. And that will take typically between 6 and 8 months. It does depend on a whole factor of elements or a whole variety of elements. And the short answer would be, how long is a piece of string? But if you take 6 to 8 months as a start for a basic implementation, you wouldn't be far wrong.
Thank you. And then another question is, could you speak to, I know that contractor wait time is a very big issue and a huge expense on sites. Apparently the cost savings on contractor wait time are quite significant too.
They're massive, Caroline. So we had one customer in particular whose wait time was anything up to about 5 hours in the morning. So just imagine you've got teams of artisans sitting, waiting for up to 5 hours to get a permit before they're allowed on floor to start their work. And remember that they're billing that time as well. So they're billing up to 5 hours in the morning for sitting on their backsides, having tea and not being able to do anything. That's a huge lost cost for the business. Ultimately, that particular customer got their longest wait time in the case of a shut down to about 45 minutes through using a digital permit system. And the comment that came from them was that just the savings on that on their user artisan wait time more than paid for their system inside of a year after implementation.
Wow, that's quite incredible. Thank you for that. If there are no further questions, I'm going to say thank you everybody for joining, and we do look forward to interacting again with you soon. Thank you very much.
Thank you all.
Thank you and goodbye, everybody.
Thank you, Percy.
Thanks, everybody. Cheers.
Bye-bye.